Okay, so the question of the day, and Monday and probably Tuesday, and we'll just figure out the rest of the semester, is what is slope? All right, so man, you've got an idea of what slope is. You've been doing it forever, right? Algebra 1, probably pre-algebra. I just want to talk about like ideas of slope. I think probably at some point if I say what slope is, you think, well, maybe y2 minus y1 over x2 minus x1. You might, think slope, think of that formula. You also might think of slope, if I give you an equation and I say y is equal to 3x plus 5, and I say, well, what's the slope? You say, well, it's 3, right? Because you know about slope-intercept form. Or I give you a picture, and it's a picture of a line, and I even kind of draw it this way, and I say, what's the slope? And if you have like a grid, you can kind of count and say, oh, I went down 2 over 5 or whatever that is. So you've got this idea of slope. So, you've got an idea of slope because you've been doing it forever. All right? But then, what happens if I give you this picture? What if I give you kind of my favorite picture, and I give you a parabola, and I say, well, what's the slope of this parabola? It's different, right? I hadn't asked those before. All right, or I could give you the y equals x squared, and I say, what's the slope? And to be honest, that's what we're going to do. We're going to talk about the slope of a parabola, or pretty much any kind of weird thing. All right. Okay. So how do we approach that? Well, the way we approach it is we have to come up with a better definition of slope. All right? Because all of those, when I give you things that look like this, and I say, what's the slope? Right? Those I'm going to call those algebra 1, algebra 2 concepts. But I need something better. I need a more general idea of what slope is. So, anybody have any ideas? How would you describe slope to somebody?
The rate of change.
Now, that sounds like an algebra 1 concept too, doesn't it?
Yeah.
Although rate of change, you're getting closer. Anything else? What if, and this is going on the rate of change, so you're definitely on the right track. What if we describe slope as a measure of steepness? How steep something is. See, like you can look at it, you can think of this line, and if you're going uphill, your slope is positive. If you're going downhill, your slope's negative. So if you look at this is kind of like a moderately, gradual downhill slope. So we're going, we're not too steep, but we're going downhill. You can think of this as you graphed it. It would be a steeper uphill slope. So if you think of slope as measuring steepness, well, we could probably talk about the steepness of a parabola. Now, the difference is the steepness changes depending on where you are. See, with a line, your steepness is kind of the same no matter where you are. But on a parabola, you can think about, well, it's kind of steep here, it's really steep here. Imagine you're walking up the hill. It gets a lot harder to walk as you get this way. It's zero steepness here because we're kind of flat, and then we're going downhill, so there's a negative. So what I'd like you to do from this point forward, when someone ever mentions slope, I want you to think of slope means steepness, how steep something is. And we need to figure out how to measure how steep something is. So, right? So like with the parabola, it depends on where you are. So the way we talk about steepness is we talk about the slope. We look at a tangent line because we're still used to counting slope, like we want to count how far down and how far over. We still need to count. But how do you do that with a parabola or any kind of curve? Well, what you do is if you're interested in how steep a graph is at a certain point, you want to think about the tangent line at that point. And a tangent line is, the line that just grazes it, like here, right? I'm going to use this as my little line. So my line grazes just here. And if I find the slope of this line, then that actually could give me a number to tell me how steep it is at this point. So with that being said, all right, so I'm going to start with my sort of just a generic function. And let's see, here's my lovely little parabola. And I'm just going to pick some random spot on my parabola. So my random spot on the parabola is going to be at this point x. And I get this big, it's a purple dot, but you probably can't tell the color on your end. So here's my x, dot. And what I want is I want to find a way, I want to measure the slope at this one spot. And so that means I'm looking for the slope of this tangent line. So I'll draw my little tangent line. Now, I have a problem because the way you find slope, while we can change the way we think about what slope is, how we compute slope really can't change. Like the only way we can compute slope is what you did back in algebra, where it was this y2 minus y1 bit over x2 minus x1. And this formula implies that you have 2 points. And right now, I've got one dot. Now, as far as the notation goes, if this is my function, so I'll call this f of x. So if I plug x into the function, this becomes the point x comma f of x, where f of x is the y value, x is obviously the x value. And you can't really compute slope with just 1 point. You need 2 points. So, what do? Well, turns out anytime you've got a function, you've got an infinite number of points. In fact, that's what a function is. A function is basically a whole bunch of dots put together. So if we were to pick another dot on our function, then I have another dot on this function. I could find the slope between that green dot and that purple dot, and I could find the slope of that. Now, the problem is, if you look at it, you can clearly see that the slope of that green line is not the same as the slope of the purple line, which is what we're looking for. But there's some animation that's about to happen. So first, I need to talk about this dot. This dot has an x value and this dot has a y value. We need to find the x value, and this dot has this particular x value. And how we define that x is going to tell me how I get my y value. And here's how I get the x value. I want you to think of this line. This is a number line. And so the distance from here to here is x. And what I want is the distance from here to be h. So if this part's x and this little part's h, then the total distance from here to here is going to be x plus h. And so if this x value is now x plus h, I can plug that into my function. And so this green dot now becomes, the x value is x plus h, and the y value ends up being f of x plus h. So I have this purple dot that's got a coordinates x comma f of x, and then I have this green dot that's coordinates x plus h comma f of x plus h. And here's what I need everybody to do, is I want you to find the slope between these two dots using this formula. Right? So I'm going to hit pause. I'm going to give you, 30 seconds. So to find the slope, I know I'm going to need the board space, so I'll have to erase this. So I'll do this y value minus this y value So I end up with f of x plus h minus this y value, which is f of x, all over this y value, which is x plus h minus, that x value and that x value. And this gives me f of x plus h minus f of x. The x's cancel all over h. Now, this, typically you do this in pre-cal at some point. Unfortunately, last year things were weird. The last few months were weird, so you may not have seen this. This has got a special name. I always think it's kind of funny. Math people are not creative at all. It's called a difference quotient. And the reason it's called a difference quotient, difference because you're subtracting something, and quotient because it's a fraction. They didn't think too hard about it. Now, if you did a different order, let's say that you did f of x minus f of x plus h, it's the same thing. What would have happened is you probably would have got a negative h in the bottom. This is the version I'm using, so what you did wasn't wrong, but this is what I'm going to use. And this thing tells me the slope of the green line. Now, problem is I don't want the slope of the green line. I want the slope of the purple line. Because the slope of the tangent line, that's what I'm looking for. That's going to tell me how steep it is at this point. So how do we do that? Well, what we need to do is we need to move this dot closer and closer to the, we need to move this dot closer to this dot. And so how do you do that? Well, but first, let's make sure we've got the sort of the visualization of what's going on. Here's that green line, and if I move this dot closer, if I can move this dot closer to this dot, then that's going to take my green line and make it closer to the purple line. I like this animation. This is my let me reset. This is my favorite piece of math software. It's called Geometry Sketchpad. They stopped supporting it about 3 months ago. So I officially have outlived software has died. I still think it's the best piece of math software I've ever seen. It's this interactive chalkboard. You can put stuff in and stretch it and whatever. But so here's our generic function. There's our tangent line, and we're going to create. Here's how they create their new x value. Then we get they're going through all this process so they can get 2 points so they can actually find the slope. They're going to draw that little green line, and the goal is I want the green line to match up to the slope of the black line. And the way we're going to do, I want to move this point closer to here. How you can move this point, how you can move Q closer to P is, since this distance is h, I want the distance h to get really, really small. And so if I click this and h goes to 0, see as h gets really, really small, you can see how that forces Q to get closer to P. And as Q gets really, really close to P, then the slope of the green line becomes the slope of the black line. Okay? I think I can try to animate that, but this piece of software does it so much better than I can. So, if you're curious, the amount of work to create this, here we'll show how much. There's a lot going on in the background. This is, there's a lady out in California that created all of these things, and she just does an amazing job. We'll start seeing some of these animations later. And I don't think I don't need the board anymore. So back to this picture. I have my lovely parabola. And and I had this dot that I was looking for. And we created this, so this was x, comma, f of x. This was x plus h, so I have x plus h, comma, f of x plus h. And here was this little green line. And when we found the slope of the green line, that was f of x plus h minus f of x, yeah, all over h. And here's the trick. The way we move the green dot closer to this dot is we make h really, really small. So I need to put in, I take the limit as h goes to 0. And as h gets really, really small, that's going to force this green line, the slope of the green line, to match the slope of the black line, which is going to give me, the slope of the tangent line, which measures how steep the graph is at this point. And this is a big deal because this little formula is going to tell us, this tells us how to find the slope. This tells us how to find the slope of any function. So, and I want to pause just here. I want to make sure everybody's okay with function notation before I start everything. And I do realize most people are, what I find is if I don't talk about function notation, then this goes poor. About 2/3 of you are fine. The other third, it goes poorly, and you think it's some really complicated math concept, and it's not. It's just notation. As far as function notation goes, if I give you, let's say I define f of x to equal 3x squared minus 5x plus 3, plus 4. The way I talk about function notation, the reason their x is here is because there's an x here. Another way I want you to think of a function, I want you to think of this as f of a silly box is equal to 3 times a silly box squared minus 5 times a silly box plus 4. And the reason I say silly box, or actually I call it magic box, the reason I call it a magic box is if I say, well, what's f of a? Well, that means a goes in the magic box, and if whatever goes here magically appears in these other spots. So if I want to know what f of a is, it's 3a squared minus 5a plus 4. Okay, that's fine, but what if it's a little more complicated? Like, what if it's f of, like, a plus 2? Well, same thing. A plus 2 goes here, a plus 2 goes here, a plus 2 goes here. Like, whatever goes here goes in the magic box. And where we're going to end up with this is, what if it's f of x plus h? Well, that means x plus h is in the magic box, so I get x plus h, and I get x plus h. And if that's really boring and you knew all of this, perfect. You're exactly where you need to be. If this was the first time you looked at it and you said, oh, I never thought of it as a magic box where I'm replacing something, well, you just missed out on that. It's just notation, but it's something that we need at this point. So I need to make sure you have. All right, so let's go back to one of my first questions. And I gave you a parabola, and I said, well, what's the slope of the parabola? And I was like, it was different. What if I gave you a function, and I said f of x is equal to x squared, and I asked, well, what's the slope of x squared? Because that's the same thing as asking if I give you a graph of parabola, what's the slope of the parabola? If I say, what's the slope of x squared? It's like, well, I'm not quite sure, but I have this little formula over here that helps me figure out what the slope of something is, because when I do this, I am computing slope. So here's how it works. You say, well, if I want to compute the slope of any function, I do limit as h goes to 0 of f of x plus h minus f of x over h. So I know what f of x is. I need to know what f of x plus h is. Well, magic box, I'm going to stick this in for the x squared. That's going to give me x plus h squared. So now I know what f of x is. I know what f of x plus h is. I'm going to plug it into my formula. And when I plug it into my formula, I end up with the limit as h goes to 0 of f of x plus h, which is x plus h squared, minus f of x, which is x squared, all over h. And I need to compute this. Now, this is why I made you do all those limits a couple of weeks ago. Because pretty much every one of those limits that we did a couple of weeks ago is going to show up when you're trying to find out what the slope is. So to find the slope, I need to compute, and the limit as h goes to 0 of this. Now, the way you compute limits, like if as h goes to 0, you plug in h equals 0. Well, what you're going to find is when I plug in h equals 0, let's see, I'll get x squared minus x squared over 0. I get 0 over 0. I'm going to have to do more work. And pretty much every single time you want to find the slope, you're going to get 0 over 0, so you're going to have to do more work. So all of those skills that we practiced past couple of weeks, we're going to use in computing this. So here's how, I want to finish this. So to finish this, I end up with the limit as h goes to 0. Let's see, I have to multiply that out, so I get x squared plus 2xh plus h squared minus x squared all over h. And that's going to give me the limit as h goes to 0. Let's see, the x squareds cancel out. I end up with 2xh plus h squared all over h. Should have done a better job picking where I'm going to write on the board. And this is going to give me the limit as h goes to 0. I'm going to factor out an h, so I get 2x plus h all over h. I can cross the h out. And then when I plug in h equals 0, this goes away. And so I just found out that if my function is x squared, and I want to know what the slope of that function is, I do this whole procedure, and I just found out that the slope is equal to 2x. Well, I'm not used to a slope equaling something with an x. See, I'm used to, here's an equation of a line, right? And what's the slope? My slope's like 5 or 2/3 or -1/2. I'm used to my slope equaling this nice little number. Usually it's a fraction, but that's what I'm used to. Well, let's talk about why your slope has to equal something with x. Think about what the graph of y equals x squared looks like, because that's what we're dealing with. So you want to think about what the graph of y equals x squared looks like. Okay, so here's 1. Here's 2. The steepness kind of depends on where you are. Because if I'm at x equals 1, and my slope is 2x, my slope depends on what x value I'm at. So if I'm at x equals 1, this formula says that my slope of the tangent line should equal 2. And if I were to draw my tangent line, I'd think, yeah, that does look like it's got a slope of 2, right? Up 2 over 1, that's about steepness 2. What if I'm at, what if I'm at x equals -1/2? Well, if I'm at x equals -1/2, if I were to draw that line, draw that tangent line, well, if I plug that into my formula where my slope is equal to 2 times -1/2, that gives me -1. Does that orange line look like it could be a slope of -1? Right? So what you end up with, right, whenever you like finding slope, you typically find out that now slope is not just a number. Now slope is some sort of formula with x, because to know what your slope is, you have to say where you are, because your slope is different depending on where you are. All right? So, your turn. kind of, yes.
Excuse me. My internet blacked out for like 2 minutes. How come h is squared too?
When you square, I erased it. When you have x plus h quantity squared, when you multiply that whole thing out, you end up with x squared plus 2xh plus h squared. That's where the h squared came from.
Oh, okay. I meant like how come it's not just x squared plus h and it's x plus h squared?
So x plus h, so this whole x plus h thing, when you square it, so this all came from, and I have to erase it. This came from x plus h squared minus x squared all over h. So are you asking how to square this?
Wait, then never mind.
Okay. All right. What? Because this came directly from here. Like I squared this. So now, so here's what I want everyone to try. Let's say I tell you f of x is equal to 5x plus 3. Right? And just for laughs and giggles, I want to do f of x plus h. It's going to give me 5 times x plus h plus 3. I want everyone to use this formula with that function. So I've already given you f of x. I've already given you f of x plus h. And what I want you to do is plug it into this formula and come up with an answer. And I'll give you, probably only have like, I forgot to hit record on that one. What if I gave you a function, I said f of x was just equal to 7. And I said, do this computation. What's your answer going to be? No, think about it. Anytime you're asked to do this computation, they're asking, what is the slope? And that's what they're doing. They're saying, what's the slope? So, and if you think about, well, what's the graph of this? Well, let's see, f of x equals 7. That means we get this. Now this is just a horizontal line at 7. And so what's the slope of that? It's 0. Now, you could compute it. Right? There's nothing wrong with computing it. I mean, the computation isn't hard, because if f of x is equal to 7, then f of x plus h is 7, because f of x is always 7. So if you plug it in, you get the limit as h goes to 0, and then this gives you, f of x plus h is 7 minus 7 all over h. You get 0 over a number. This whole thing ends up being 0 anyway. That's kind of the point today. The main goal of today is I wanted to talk about slope. Now, here's your homework. Your homework is it's this one assignment out of your textbook, and it's all about using this formula. They give you functions. They give you